Good morning, everyone. My name is Adam Shepard. I am the technical director at BCO-DMO, alongside Danny Kincaid. So I want to talk to you about my favorite subject today for 30 minutes, which is awesome. And my favorite subject is movies, not necessarily fair. But what I want to do is I want to share a story with you about mid-80s Americana that I felt like really sort of crystallized the struggles and challenges that we see at a data community for serving this data, accessing it, using it, especially in light of FAIR. And so I thought this story crystallized the need for FAIR, and I hope you do too. So let's jump right into it. So I want you to close your eyes if you feel comfortable doing that. Imagine it's 1984. And just to give you a context of what 1984 was like, the hairstyles are a little bit different back then. We had a thing called rotary phones. I don't know if no, it's like rotary phones, okay. The extension cord on a phone was like 100 feet long. Like I could be in the hotel from here on a phone. What else was different? Apparently you wore scarves around your neck to school. That was a pretty common thing. Okay. And I gave this talk in Austin, Texas, so it's gonna have like a little Southwestern feel, but just go with it for me. All right, so you've got your eyes closed, it's 1984, you're 16 years old, you just passed your driving test, and I think back then you could have other passengers in your car, like right after you got your license, I don't quite recall, but it's a Friday night, school's over with, and your friends are gonna see their friends, you don't really quite know, like it's the boys group meeting up with the girls group, and it's Friday night, you're gonna go to their house, you got the address, you're not quite sure where it's at, but it's on you guys to sort of provide the entertainment, the food, and the whole thing. So the first thing you gotta do is you gotta secure this food here, right? And back in the day, 1984, there was this little gimmick in America where you could call and order a pizza and it would get delivered to an address. Amazing, like you didn't have to go pick it up. And they had this gimmick where if it wasn't delivered within 30 minutes, the pizza was free. And this was just sort of like to get the whole like pizza delivery thing going. So anyway, you're like, okay, no big deal. I mean, I have this address, so you call up and the kid that answers the phone is a little dweeb. It's like a word for like, I don't know, just sort of not with it, not cool, not hip. A little dweeb, and he says, so what do you want? You give him the order, and he's like, okay, where are we delivering it to? And you give the address, 1428 Elm Street. That's a little nugget there for you movie buffs, but I'll let you figure that one out on your own. And you say, great, okay, the pizza's ordered, it's gonna be there in 30 minutes. You know, you've got your car, you're ready to go. You're dressed like Patrick Dempsey there with a long trench coat, big scarf. You're ready to hit the track and secure the entertainment for the night. Now, the group that you're going to meet said to you, hey, get the one with like the righteous girl on the cover, bodacious dude, there's like light beams flying everywhere. Come on, man, you know what this movie is. We all saw it a couple of years ago in the theater. You know, the one with the Force. And so, you don't want to out yourself, you really don't know what they're talking about. And so you head out to this place, and it's not Netflix, it's not Redbox, sorry. But you had to go to this physical location and like walk up and down the aisles and look at these big plastic boxes at the covers, a video store, like the data was recorded on like a magnetic tape that we actually brought to our houses and like put in a machine, and just so much work. It wasn't just like hit the power button on Netflix and play. So you take this description, righteous dude, light beams flying everywhere, the one with the Force, and you're frantic because you're thinking the pizza's gonna arrive at this address in 30 minutes, which is supposed to be the length of this talk. I don't know how we're gonna do that. And so you're looking for this Force movie, and you say like, aha, I found it. It's like, righteous girl, bodacious dude, there's light beams, it has Force in the title, we got it, like check, we're golden. Well, little do you know that like at the beginning of this thing, some unfortunate events happened. Because back at the house, your friends that you're meeting up with, they don't know that you have no idea what Star Wars is. But they're really bumming because the pizza that you ordered for 1428 Elm Street hasn't shown up yet. And that's because in Austin, Texas, if you were to order from El Señor Pizza, there are literally two different Elm Streets diametrically opposed to each other in two different towns, both 40 minutes away from each other. And unfortunately, this pizza went to the wrong Elm Street. And because it was 30 minutes or it's free, that house totally got a free pizza on your dime, and you are just out of luck. Like, no pizza. So this Friday night, you've got your license and a movie and pizza. It's not going so well, but you know, at least you have some entertainment. Like maybe they can order something else, or you can cook up something in the kitchen. So you show up and you're like, "Hey guys, I'm sorry about the pizza, you know, but I got this movie here. Let's pop it in the player." And they're just cracking up, like, "Okay, this isn't Star Wars. Who is this person? You have no idea what you're doing. Megaforce doesn't even come close to Star Wars." And I'm telling you right now, please don't rent Megaforce. It's awful. We've got a fan. We've got 30 minutes if you want to come up and defend Megaforce. We can totally do that. But unfortunately, in 1984, there was like this heated competition of like magnetic tape players. There was a Betamax player on the left, which high quality, great quality. I sound like our president. I'm sorry, I'm not gonna say it. A Betamax player and VHS players. And unfortunately, this house has a Betamax player, but you grab the VHS. So even though you have this movie, you can't watch it. Like there's nothing you can do. So I guess I don't know what you do in this situation, but you're out of luck. And so essentially what happened here? So I'm coming from a data perspective, and how does the story correlate to what we see in the data world? And the slide is a little misformatted, but that's all right, we'll roll with it. And so with the pizza, I think what happens is that ambiguous address sort of gives us no results. And I equate that to, like, you're searching for data, and like, it's not that you don't get any results, but you almost get like too much. Like you put in the word chlorophyll and you get like 10,000 data sets and your eyes glaze over. And I don't know, for me, I'm like, all right, I'm gonna move on to the next part of my day. It's really hard, right? Like, what does the machine understand when you type in chlorophyll into a search box? Now with the Betamax player, it's okay, maybe you found a data set that seems like great, and this is exactly what I want, but maybe it's in a different format and it's completely unusable to you. And maybe in 1984, that's the case. Maybe not today, but yeah, just not having usable results for that data. And then finally with Megaforce, the substitute for the great Star Wars, you know, you have results, but it's not quite what you expected or at the level or quality that you need to do your work. And so the question becomes, why do we need FAIR? And it's to address these very particular reasons. And I don't want to get into FAIR because other people are going to talk about FAIR in more detail, but I want to share with you this idea that came from C.K. Ogden, and this was literally 100 years ago, where he came up with this diagram here, which essentially says that when humans hear a word like cat or dog, what we do is we actually, in our brains, picture a cat or a dog, and we don't need to hear, or we don't make this direct correlation to, oh, okay, a cat. We actually picture this in our minds, and what he called that is the conceptualization that happens in the neural pattern of neural activity in our brain. And so it's interesting because I wanted to make sure that we put words of cat in different languages up there, and I'm not a language person, so I don't quite picture, when someone says gato to me in Spanish, I don't picture a cat. I'm like, I don't know what the heck that is. Or let's see, I guess in German, if someone said Katze, I'd be like, all right, maybe it's a cat. But I think it's just a really great depiction of what happens to people. We have this context in our brains that helps us derive meaning for words and the things that we interact with in life. But computers don't have that. So when we type the word chlorophyll into the computer, it's just trying to do its best to like match and figure that out. It doesn't have the conceptualization of what chlorophyll is. But the good news is that data folks can provide computers with conceptualizations, and you'll hear some great work today from folks that are doing this. And so I just want to illustrate a little example. This is 10 years ago, so We're in XML world. But essentially, what's on the left might be the same thing as on the right. The way I built that was literally just to Google Translate my name in Chinese. So I have no idea if those characters actually are my name in Chinese. But computers, are going to see that and just try to do their best. So, and even though the pattern might be the same, the computers are it's still a mystery to them because they don't have the context of the other data in English to compare, or Chinese, vice versa. And so what I want to say is that machines can, though, detect if disambiguous symbols, and we'll describe that in a bit, are the same. And so what we can do is we can point these labels like name or the data pieces like Adam Shepard to disambiguous symbols, which could be like a URL, a URI, or something else that gives the computer a context for what the meaning of that thing is. And if you've studied some of the latest work out of AI and LLMs, what they're doing is ingesting a bunch of information and then drawing correlations, similarities to what it's seen over and over again. And this is a technique, that technique works, but this is another technique of giving the computer a disambiguous symbol, like a URL, to explain or provide context for what something means. And fortunately, this works for humans. We can look up those disambiguous symbols like the word cat or gato, or a URL like schema.org/name to understand what a piece of information means. And I just want to say this is something that works today, like now. It's been working for, or been being worked on for a good number of years now. So if you were to go to Google and type in the name of a hotel or like looking for rooms nearby, it can understand based on the data that it's mined and the way that it's been presented on these web pages using this technique of disambiguous symbols. It can understand, oh, this person's looking for a hotel reservation. So let me provide more information about what rooms are available, things like that. And that's great for the commercial world. But thankfully, this is also happening in the data space too. So Google, I want to say 2018, 2019, began work on this tool called the dataset search. And so that's a URL that you can go to right now. They've been harvesting data sets, scientific data sets on the web for a while using this technique. And the disambiguous symbols that are being used here is in that schema.org space that Pierre mentioned earlier. And so you can go there and type in these words and get better, what they call precision and recall in the search results. And there's other techniques. There was a slide in here that I put in this morning, but I realized these were downloaded. And it's just a shout out to Pierre's great work at the Ocean Info Hub, which I think you'll hear more about later, of some work that he's doing in that space specifically for ocean data, which is great. And so, okay, we've got this idea of, all right, there's challenges in the data space about how we find and access and use data. We have this idea of, okay, we need disambiguous symbols, but what the heck does that mean? Like, as a researcher, you shouldn't have to care about that. That's the space where us data folks can come in and really help you. And it points to the value of having domain repositories in the pipeline of getting your data published and archived. And for me, I would describe it, and folks might disagree, and I'd love to chat about this, is for me, we need to come to community agreements on what the symbols are and what they mean and how we use them. So that when we're looking for Star Wars, we don't end up with Megaforce, on our desktops. Yeah, okay. So I have no idea how long I've gone. It's probably not been anywhere close to 30 minutes. But I want to just sort of end with a couple of statements reiterating. So I believe that we need agreements about the data set contents. And that sounds like, oh yeah, we've been using standard metadata templates forever now. No, that's great. Across the goal line. We've been using standardized metadata for a while, but maybe what we haven't quite nailed down is how to communicate what those individual elements in the metadata standards mean in a way that computers can understand those and build a context for how it perceives those symbols to mean. We want to take these agreements that we make this week and codify them in ways that the computers can understand. And so when Heather mentions the templates, I know it sounds like a brand muffin on a Monday morning, but this is what we're doing. We folks can take that information and codify it in ways that can help the computers make sense of those symbols there. And then finally, I just want to say, like, domain repositories are here to help. We see this all the time about the data that's submitted and the way that people access data. We understand the challenges. Me personally, as a technical director at BCO-DMO, like, I'm frustrated by the way search works, and especially on my site, and I am really motivated to make that better by using these techniques. And then further pushing that context out to you guys so that it's available to you when you download the data, so that it can be reused in pipelines and just automating. And I'm sure you'll hear much more on this topic by folks smarter than me in this space. So really excited about this week. Thank you so much to listening to my story about movies and 1980s Americana. That's it for me. Happy to take any questions or jump in with references. Yeah.
In your pizza movie scenario, could AI have solved that?
Yeah, that's a great question. I was thinking about that on the plane. So I wrote this talk, gosh, like 10 years ago when LLMs weren't really around. And I think, and I'm folks that are in this data space that might know more about LLMs than me chime in. The way I understand them is that they're like great summarizers. So they're seeing all this context and just sort of like trying to piece together what you mean by chlorophyll or this piece of thing. So I think it can do a better job. But I'm unsure about like the precision and the recall. They'll do better than what we've done before on just sort of like string pattern matching. But I think the semantics and the symbols like really hone in on the precision and recall to like nail what scientists are asking for. Go ahead, Pierre.
Yeah, just on that. So, keep in mind, when we say AI, typically we mean machine learning, right? So we just use it because it's the popular term. But machine learning relies on learning from training sets where people are talking about the same things in more or less the same way, right? If they don't, then you have a problem. And also when you get to specialist fields, like scientific fields, things get weird when you ask an LLM that hasn't been trained specifically on the lingo in that field. And often there isn't that much for it to reach that threshold. It's like when you ask it to generate a picture of a full glass of wine. Many of these generative systems don't. They can't, because nobody fills up their glass of wine to the top. So it doesn't understand what you're saying because it hasn't seen that before. So they're very, very useful tools. I think they will revolutionize, but we need to help those tools by providing the data sets that we want them to learn from, which means if we do this work that this consortium is trying to do for the time series, LLMs will pick that up, they will learn from it, and they'll know what we're talking about, and then be able to generalize it and connect it to other systems.
Yeah, Justin.
So AI can learn brilliant things that we can do routinely. So when you first train that model, there's probably an equal chance to get Star Wars, Star Trek, and those.
Yeah.
As the rentals go out, and as it's been rented out 1 million times, then it will converge Star Wars, and you get that. But that initial kind of rental you do when it's a brand new film, you probably still get the wrong film. 2 or 3 years later, you get the right film because training data set is iterated, and you've actually.
Yeah, there's one minute.
Yeah, please. And if you want to come up to the mic, just for clarity,
I don't know if people online can hear the questions.
That's what
Oh,
the
yeah.
owl's for. I think the owl's picking.
Oh,
it
the
up.
owl's picking it up. Oh, great. Okay.
Those things really freak me out. But yeah, so that's like a way around that is something that some of the posters there also mention these things called ontologies, right? Ontologies and vocabularies like nerd are like that a little bit. What they can do is they basically say, all right, not a lot of people are talking in the same way, but we definitely mean this. And they kind of spike the learning algorithms for specialist knowledge, especially the ones that are more expressive. So there are ways around it, but they don't come for free, right? So if this is why we're here in this room, and it's great, thanks Heather and all for bringing us together, because if you tell us what you as a time series consortia want the machines to hear when you say it, we can start to spike the training networks, etc. Right? That's why like those metadata sheets, those sort of agreeing on names, as Adam just said, when we know that, we can start to transport that to the datascape layer and get the machines to play a little bit more nicely. they're running marathons now in China, so we better hurry them.
Thank you all for hearing my story. I don't know who's next, or if we want to move on, or if there's more questions.